Hey there. Let's talk about compiling, linking, and executing. This video is going to focus on Linux, but I think it'll be useful for all other operating systems that you might be working with at home. I'm just going to basically explain, like, what does it mean to compile? What does it mean to link a program? What does it mean to execute a program? If you don't know that, then I think this video might be for you. Okay, so for starters, imagine you have written a program. I'm going to write the program here real fast. I'm going to say, let's do an empty file. We'll call it, let's see, I got my answer key up here. We'll call it first.cpp. First.cpp. So I'm just like making a first piece of source code, and I'm editing it in my little editor. Notice how I'm not calling this the main.cpp program, because a lot of beginners, they always do main. I want you to know that you don't actually need a source code file called main.cpp. Even if you're writing a C++ program, all you really need is just one instance of the function main. Beyond that, also, you only need an instance of main if you're writing a hybrid program or some kind of program that is in pure C++ or that has the GCC libraries. GCC libraries call on the main function as your entry point, but if you're writing pure assembly, the entry point is actually _start as a label. We're not really going to do, this is not an assembly tutorial. I just wanted you to know real fast. Okay, so I'm going to do like iostream, and then I'm going to say stdcout, and I'm just going to print, hello from first.cpp. std end l. Okay, so we kind of have like a hello world program that'll just basically print a message and do nothing else. How do we compile this program and execute it? What does that actually even mean? Okay, so for starters, the first thing that you probably do when you're compiling a program, you've probably been told to do something like this. Let me get my little command line open here. You've probably been told to do something like this. Let's compile with GCC or G++, and we'll say the standard for C++ that we're going to use is 23. There are a bunch of other standards you can use. We can turn on all warnings. We can have the compiler be pedantic in terms of the warnings that it gives us. These two things at the end don't really matter that much. It's really all about G++ and then std C++23 to get it compiled. And then we'll give an input file. We'll say first.cpp. And then I think probably usually this is where most of you stop. We just kind of like specify a couple flags, specify the input file, then hit enter, and it compiles. If we list the contents of the directory now, this might be familiar. You'll probably see something called a.out. A.out, notice how the permissions look a little bit different for that file. It's kind of printed in green in Ubuntu. And if you look at the left side right here, you can see that it's got a bunch of X's in the permissions area. That just means it has execute permission. The compiler does that automatically for you, but essentially this is like just, an executable binary file. It's not a text file, it's just something that the computer is meant to run. We can look inside of it real fast. There's a program called XXD on Linux, and it'll sort of spill the contents of that file. So if I say XXD and then I go a.out, it just spills like a whole lot of like binary nonsense, right? You can see at the very beginning, ELF, that's, I think that's executable linking format for Linux, and then there's like a bunch of stuff, and it just doesn't make sense. This is not text that you can read. Here's like some sort of a shared argument that it's using, and then some register information. I don't even know what most of this is. Somewhere in here, if you look carefully, you'll probably see that message. Where is that? Oh yeah, hello from first.cpp. So it's saying that the message we typed in the program is actually embedded in the executable. That makes sense. So hopefully I've proved to you that this is just an executable program. How do you execute the program? Well, usually you'll have to type, the full path to the program that you want to execute, because your custom program is not in the system library paths. So your system's not going to know where to find it automatically, even if it's in the current folder. So you would usually do something like, the full path to your executable, like a.out. But there's a shortcut we can use in Linux. The dot directory usually just means, or it always means the current directory. So if we say dot and then a slash, that's the same thing as typing out the full path to the current directory. Then it's really easy to just type the name of the file that we compiled. Okay, so a.out. We executed it now. So that's what it means to execute. We just compiled without a lot of options. We're going to try to do that better in a second. And we know that you need execute permissions. Let me show you what happens if we take away execute permissions. I'm going to use a command called chmod, like change the mode. I'm going to say take away execute permissions from the a.out program. Then if I list the directory again, notice how there are a bunch of X's missing now on the left side of that a.out permissions area. Notice how it's not in green anymore. Depending on your system, it might not be green or gray or whatever, but just look at the permissions. So now if I do a.out, it'll say permission denied. Maybe you've seen this before, especially if you're syncing with the cloud that doesn't carry execute permissions from one machine to another, which happens to me all the time. We can reverse this with just the chmod, plus X execute permissions. And then we can just execute it again. The funny thing about execute permissions is you can actually execute a bash program, which is basically a text file, without needing to execute a binary program. So this is not a bash video. I'll make other videos in the future on my channels for bash. But for now, just know that something you compile is not the only type of thing that you can actually execute. In fact, in Linux, under the hood, a lot of system tools are just written in bash or Python or something else that looks like a human readable language. And they are not necessarily all compiled languages, like C++. Okay, so now that we kind of know that we're compiling a program, let's be a little bit better about specifying the name of the output file. So I just want you to see one more flag here. And while I'm doing that, I'm going to create a script that will compile our program for us. So I'm going to say nano, and I'll just name a file. I'll name it compile, and it'll be our compiler program. Okay, so what we did before is it was, I think, G++, and then we named the standard is C++23, and then we said wall. Wall just means give me all warnings, which is good to help your, to help you write better code. Same thing for pedantic. Just helps you write better code. It gives you more annoying warning messages, but it's pretty good. Okay, so this is where we stopped last time. So I'm going to say, now let me remove a.out. Now, instead of typing the command by ourselves, we can run the compile script. The language I've just written was, well, I haven't really written in any particular language, but if we use a shell interpreter called bash, which is actually what's running in the terminal right now, it'll interpret any command line that we give it as just something that we want it to execute to the system. So if I type bash to run the bash interpreter and I just specify the name of the script, it should compile the program automatically by executing that one line that I put inside of it. See, now I've got the a.out again. If you rewind the video, you'll see the a.out wasn't there when I originally ran it. One more time just to prove it to you. Bash compile. Now you can see that it's back. Okay, so let's make this compile program a little bit better. Instead of typing bash every single time, I think I just want to try to execute the compile program directly. I can do that pretty easily. There's something in our script that we can put that will designate what interpreter we should use to run the program. So right now it's just like some text and it doesn't really mean anything. There's something called the shebang, which just means hash bang. And we can just provide the path to some interpreter. I'm going to type shebang and then a path to the bash interpreter. If you don't know where bash is on your system, you can go which bash. And I guess mine is a user bin bash. I think I can get away with bin bash. Let me see. Let me just type it out to make sure. Bin bash. Yeah, okay. So if I type exit, I'm actually in another version of bash, which is inside of bash. If I do exit, I should just kind of stay where I am. Yeah, okay. So bin bash will work. User bin bash will also work. I'm going to go back to editing this compiler program. And now all I have to do, because the system is going to know what interpreter to use to execute my little script program here, all I have to do is add execute permissions on it, and it should work. So let me first remove a.out, and then let me try first to execute compile. It should not work because I don't have execute permissions. Remember we talked about that before? So if I do that, it says permission denied. Oh no. So I'm going to give it permission to execute. I'm going to say change the mode plus X on compile. If I list the directory again, notice how it's green. Notice how there's a bunch of X's everywhere. So now I should be able to just say compile. And then it seems to have worked, and now notice how it has an a.out. I'm coughing. So a script is really useful for you because it's a pain in the butt to type out all the compile commands every single time, especially if you have a complicated compile command or many files that you want to compile in the same shot. So, of course, in another video, I'm going to talk about make files. Build systems, proper build systems are a lot better than just making a script. But for now, let's just make a script because I just want you to understand, compiling, linking, executing as a basic concept and just some of the surrounding ideas. Okay, so let's see. I'm gonna go nano compile. And the next upgrade that I want to make is I want to specify the output file because it's kind of a bad idea to not specify the output file and just hope that the compiler gives you the file that you wanted. I don't know. So I'm going to do -o main, and that's going to give me a file called main, which is going to be my program now. So if I remove a.out, just to keep my area clean, I can now do compile. And if I list again, notice how I've got main. So I can execute main, and it's the same program that we already had. In fact, maybe sometimes, just as a shortcut, since this is a script, what if I'm always hitting ls-la? I always want to list the folder after I compile. I could just put that into the script. The more commands you put into the script, the more convenient things can get, unless I guess it gets too messy. So I'm going to list first, and I'm going to remove main, just to prove to you that we're doing this from scratch, and then I'll do compile. Notice how it compiles and then lists everything for me. Seems like it didn't actually turn the compile green. That's probably another flag that we have to stick in there. Let me see if I can do that real fast. If not, I won't waste time. This is not a ls video. I think probably color or colors is what I got to do. Let me just do that one more time. Yeah, okay. So that's just a flag on ls. That's not what this video is about. So now we're compiling directly to main, but here's the problem though. We're actually kind of sort of skipping over some steps that we could be aware of. When we compile our program, we're actually taking our source code and we're assembling it down to assembly code under the hood, and then we're compiling it to an object file, which is sort of just machine code. It's like a level lower than assembly. And then as a last step, it's getting linked into an executable named main. So we're skipping a ton of steps. Really what's supposed to be happening is every single source file. Oh, whoops, I'm on the wrong machine right now. Okay, where's that? Oh, the machine that I'm recording on. There we go. Really, we're saying like first.cpp, and we're thinking that it just goes directly to main. That works if you only have one source file, or if you don't want to have fine-tuned control over your compiling. But I would like to do something a little bit more detailed. Let's compile our CPP source file into an object file. I'll name it first.o, and then we'll link that into main. Why is that useful? Because later when we have multiple source files, we might want to compile them all to object files first, and then link them all together in one step into main. This will be even more useful when you later realize that you can use a build system that does kind of the same thing to save compilation time. I won't talk too much about makefiles here, but let me just tell you, when you start using a build system, your compile time can be drastically reduced. Story, I used to have a program a long time ago that I wrote myself. Took like an hour to compile. I would literally, every little change I made, I'd have to get up and leave and go make a sandwich or something, and then come back by the time it was finished compiling. When I started using object files as intermediate steps and upgraded to a build system, I was using GNU Make, then my compile time went down to like a minute each time. So it was like so much more efficient. Anyway, let's do that. Let's do that now. Let's nano our compile script. And you just need another flag in here for the GCC compiler to say, I would like to compile this source code to an object file and not actually produce a fully linked executable that you can execute. That means I should probably rename main to something else, because main is supposed to be my executable. At least that's what I've chosen. I would like to have every object file be named similarly to the source file it belongs to. So I'm going to type the output now is going to be first.o, and then the C flag just says only compile, don't link. This means, of course, that I'm not going to produce a program that I can run. Let's see. Oh, I'm going to end up accidentally deleting the compiler. Okay. But we can see what we're doing. Okay, so compile and CPP for first. So I'm going to compile it. And now notice how we have an object file and no main and just the source file and its corresponding object file. So I can't run this program. I have to do the additional linking step now. So I'm going to do compile. And in my editor here, let's see, where is my command that I wanted to do for linking? Okay, so I'm going to link with the GCC libraries. I'm going to use the G++ command. I'm just going to put a couple of flags. I'll explain them real fast. I'm going to say that I want a 64-bit executable, which you probably actually don't have to specify. I'm going to anyway. And then I'm going to tell it again that I want it to link up against the C++ 23 libraries. This is important if multiple modules reference the C++ libraries. I'm not even sure. I think I need it in both the compiling command and the linking command. I'm going to leave it in both because it should work. Usually if you want to embed debugging symbols into your program, you want to put a -G there, which is a great idea. But we're not going to talk about debugging in this video. You can also specify the type of debugging symbols that you want. I'm just going to put that in here right now, gdwarf2. And then there's some new flags that you kind of need. There's one here called no-pi, which I think is just an Ubuntu thing. Your program probably won't execute if you don't do that. So just put it in there and trust me. There's another one that we have to put in now called no exec stack, which basically prevents your program from executing code sitting inside of the stack, which is just sort of something to help you not get hacked, hopefully. It's not bulletproof, but you know, it might help. And then I'm going to give it input files. The input files for the linking stage, maybe I should do a comment. Linking stage. Compile the C++ program or source or something. For the linking stage, you want to provide all of the object files that you're going to link together. In this case, we just have, you know, the first object file named first. And then we can specify the output file as main. If we didn't specify, it would probably be a.out like we saw before. So if I got this right, let's see if I did. Now this should compile the C++ source code file into its corresponding object file and then scoop up the object file, turn it into an executable. Okay, so I'm going to clear and then list, and then I'm going to remove the object file. I'm going to put star.o, which is a shell trick to basically say that star.o is going to expand to really mean every file that ends in .o. So, you know, in this case, it's actually just going to end up being first.o. But it's a trick you can use to grab multiple object files or files of a certain type all in one command. So I'm going to do that, and then I'm going to list again, and then I'm going to compile. And you can see that the compile command, it created first.o, the object file, and it also created the executable main. So if I execute main, the same thing should happen. So great, we're ready to move on to another step. Let me remove star.o. I got to be so careful because I'm going to totally ruin this video by erasing the wrong thing. Okay, because this is, I should be in a Git repository, but I'm trying to be fast here. Okay, so let's nano compile. Let's create a second source file, actually. Okay, so let me get out of this. I'm going to create a second source file. I'm going to call it second.c. It's going to be a pure C program. And because we don't have C++ libraries in C source files, I'm just going to say, you know, standard input-output.o for the header. I'm going to make a function called void second, probably. And it doesn't do anything except just sort of print a little message. So I'm going to say hello from second. And then do a new line because we don't have endels in C. All right, I think that's probably going to work. So then let's edit our compiling script, and we'll just add another line here to compile the C source. Okay, so I'm going to go gcc because it's not C++ anymore. And I'm going to do all warnings and pedantic again. You don't really even need to worry about that. And I'm going to give it an input of second.c because that's the file we just worked on. And I'm going to tell it I only want you to compile with the -c flag. If I forgot that on this one, then I'll probably end up with an object file, a main, and then an a.out that's only based on the C source code. And that probably wouldn't work because the second source code doesn't have a main function inside of it. So let's see, we'll do output, and it's going to be second.o, and then I think that should be okay. You know, something that I just realized I should mention too is when you're making hybrid programs like this, or programs where there are just many, many source files, like I said before, you don't need to have a source code named main.cpp. You can name all your source codes anything that you want. The one thing that you really do need is a piece of source code. Oh, I'm editing inside the terminal suddenly. Sorry, I got sidetracked. I wanted to edit all this stuff inside of Genie because it's a little bit better. Maybe it doesn't matter. So notice how we have the main function inside of our first.cpp program, and then there's no main function inside of our other source codes. For your program that uses the GCC libraries, you need exactly one instance of main. So that means, you know, you have to have at least one. And if you have more than one, it's probably not going to link. So if I put a main inside of here, probably not going to work. This also kind of means you can arrange your source code in a funny way. You could have a bunch of different pieces of source code that you could consider maybe libraries. Maybe there are a bunch of classes or something that will help your program. And you could release multiple different executable files by just having different source code files, each with their own mains and linked separately against the object files that contain your library or classes or whatever. That's just a little side tip. But anyway, let's see if I actually did this right. We're linking this, and I'm going to see if it works. I get stuck inside of the terminal, and I start thinking I'm going to edit everything inside there. Okay, so it compiled. Well, let me remove star.o and remove the main, and then just clear it again in the list. Okay, so now I'm going to run the compiler. And after the compiler ran, everything seemed to be okay. It compiled first into its object file, and it also compiled second into its object file. If I run the main executable, notice how it only prints hello from first.cpp. Well, what about the second one that we just added? Well, what we need to do is improve our linking stage. Notice how in the linking stage right here, we just only link first.o. So we should also include the other object file that we want. I'm going to glob that in a second, but let me show you. Compile. Now if we run main, what did I do wrong? Hold on, let's see here. Second.c. Oh, I forgot to actually call the second function. So that's cool. Just wrote a bunch of stuff for no reason at all. Let me have the main function call on the second function. We're going to encounter an issue here too. The second function is written in C, and the first function, its source code is in C++. And the thing is, C++ uses something called name mangling. I won't go over it too much in this video, but it uses name mangling. So you can overload functions. You can have functions with the same name, but like different signatures, right? So it'll go in there and it'll mangle the name of a function according to its overload prototype, so that we can actually call overloaded functions. But we don't really have that in C. So that means if we try to call a C function from C++, we're probably going to end up calling the wrong name, because there's the expectation that the other module has name mangling enabled, but it's not, because it's C. So I just have to do this little block, extern C, and just name all the stuff that is not going to be name mangled. I'll just provide the prototypes of all the functions that I want to be able to call. So just void second. If you look here again, we just have void second. And now when the C++ module calls on second, it won't expect name mangling, so it should work. So we're calling it, and then we linked it. Now everything I think should be okay. I'm going to compile one more time, and then I'm going to run the main program. And now you see that we have both calls in there. Awesome. Let's give this script a little bit more output, though. This is kind of precarious. What if something failed inside of there? Maybe you don't want the script to continue if something fails, and maybe you kind of want to know where the script is at while it's compiling. So I'm going to upgrade it just a little bit. So compile the source. I'm just going to say echo compiling the compiling first.cpp. And then here I'll just do another echo, and I'll say compiling second.c. And then here I'll say echo linking the executable or the binary, aka the binary. I don't even know if that's the proper term. I just like to call these things binaries because they're not in text. Anyway, so if we do another, I'm gonna do a compound command line here. I'm gonna go clear and compile so that I don't have to continue to hit clear every single time. Now notice how it prints what it's doing. So if it kind of failed somewhere along the way, or if it took a long time, you'd kind of know what's going on. Now let's use a little bash trick, because remember, this is a bash script. It's not just going to only execute actual commands. I'm going to say or exit with the return code of the previous command. So basically here on the left side, we're going to try to execute G++. If G++ fails for some reason, then the whole program or the whole script is going to exit, and it's going to exit with the return code mentioned here. I think it's not going to print it. I'll show you how to print it in a second, but we can actually make a function called die up here in a second, which might be better. So I'm going to do the same thing over here. I'm going to say or exit with the return code of the GCC command, and then here or exit with the return code of the linking command. We'll do it one more time here. Notice how it seems to work. So now let's make the first C++ program not actually compile. I'll put a bunch of Z's there. And so if we try to compile it again, it should just quit right after it tries to compile the C++ program, right? So that saves you some time and helps draw your attention to what went wrong. The C++ compiler is saying, hey, there's like a type there. It doesn't show the exit code though. So let's make a function in bash that will die and print an exit code. So I'm going to say do die, or maybe just die by itself, something like that. Functions, whoops, I'm in the wrong language. Let me go back to the compiler. Make a function in bash called die, and it'll take one argument, and the argument will just be the exit code that we want it to alert us of. So I'm going to say exit echo. I'm going to say we are dying now. Previous exit code was, maybe I'll do a little variable here. I'll do a local variable. Exit code is going to be the first incoming argument. This is a bash program, not C++. And then here I can just say exit code. Okay. So then after writing all that, I can say or die, and then just, so I'm calling a function, and the first argument I'm giving it is the actual exit code of the thing that died. So we're just kind of like using indirection to print a pretty message to get a little bit more information. So we'll try that one more time. Notice how it says we are dying now. Previous exit code was 1. So that just tells us that GCC exited with the exit code of 1. Not super useful, but it's nice to see. Could be something else entirely, like, I don't know, maybe we misname the first source code file. Let's see if the code changes. I think it probably will. Nope. Previous exit code was 1. No such file or directory. All right. Exit code. Am I doing something wrong? I guess I'm all right. Okay, so let's just move on. I wanted it to be fancier. We could also upgrade a little bit if we wanted to. Instead of echoing, I could make a function called log here, and I could just say that the log command just echoes, and maybe we'll put a cute label and we'll say, my super cool program compiler, or how about super cool compiler? And then just do the $1 because that's the first incoming argument that you get. And now I can type log instead of echo. So that's nice. And why would you want to do this? Well, now it's going to go inside of a function, which means later on you could start adding extra commands like logger to log to the system daemon. Oh no, so this would write to your system log in addition to printing something. You could do anything you want. It's just like a regular program, adding more power by sticking everything inside of functions. I'm going to put log here, and let's see if it works. Compile. Okay, nice. Notice how we have a little message with a little header, which seems pretty cool. Maybe instead of echoing here, let's make a complaint function. Let's do complain, and same thing as the echo function, but maybe I think there's a flag where you can tell echo to print to standard error instead of standard output, but I'm just going to do it the easy way. I'm going to say 1 goes to 2. so that the first pipe standard output is going to be redirected into the second pipe standard error. So now I can use complain instead of echo down here, complain, before I die. Oh, I forgot to actually, or die. Oh, I forgot to actually exit. So that means it was, oh yeah, it's still compiling everything. What a dope. Okay, let me fix that. So in the actual die function, hopefully you were at home cringing along with me. Let's see. Let's exit with the actual exit code that was specified, just to make things a little bit more automatable. Yeah, now it stops right away, and the complainer is like, pretty cool. Let me fix the first source code real fast, and we'll say that the second source code is broken. We'll put a bunch of Z's there. All right, so now the first one compiles, the second one, it breaks, and we're starting to, get a hang for a compiler script that's a lot more sophisticated than just typing things on the command line, right? You can take this as far as you want. The next step above this is using a proper build engine. So let's see. Well, let's do another source code. Let's do let's do an assembly source code. So we'll say third.asm, and it's just going to be YASM. This is not a YASM or assembly tutorial. I'm just showing you how to, build, compile, link, and execute. We'll make a data section, so I can just stick some defines in here real fast. I'll say system right is going to be equal to a 1, and then the file descriptor for std out is going to be equal to 1. Do you ever feel like red jumps out at you on the screen? Does that mean I have eye problems? I am kind of old now. I don't know. Hello from third.asm, and I'll just put a little new line there so I don't have to do it elsewhere. And then I'll have to specify the message length, because this is not a sophisticated program that can loop through the message looking for a null terminator. And then I'll do a text section, which is where your code goes. And in hybrid programs, if I have this third function, which is marked as using a label and then a return statement, I still have to mark third as being accessible outside this module. So I'm going to do the global statement. And then I'm just going to do really quickly, I'm going to move something into REX. It's going to be system write. So basically, I would like to write something somewhere to some file descriptor. Its first argument wants where I want to write it. So I'm going to write it to the standard output instead of an actual file. And then I'm going to move RSI. The next argument is going to be the actual message, or a pointer to the message that I defined above. And check out my other videos if you want to learn assembly. This is not an assembly learning video. I'm just kind of doing it real fast in case you're interested. So I have an assembly program, probably, unless I ruined it somehow. Let's start compiling or assembling the assembly program. So just one more, we'll say assemble the assembly source or module or whatever you want to call it. We're going to use YASM to do that. gdwarf2 is the debugging symbols. Not necessary in this video. The format is I want a 64-bit executable. That's how you do it in YASM. And I'm going to give it an input of just the third assembly source file. And I want it to output the third object file. I got to remind myself to glob line 36 after this. Or die with the exit code. Okay, so now this might work. Oh, I got to put third.o in the linking stage. So I'm going to do clear, and I'm going to go clear and compile. Unrecognized debug format dward. Why didn't you stop me? It's gdwarf. Let's see, what did I do wrong? Gdwarf. Oh, dwarf-2. Oh, it's not even G, it's just dwarf2. Sorry. And I got to put a dash, I think, for YASM. Yeah, okay. Let's see if that works. What did I do wrong? Oh, no, YASM doesn't need the dash, but GCC wants the dash. Okay. Had it right the first time. Doop, doop, doop. Okay, so it probably linked. Let me run it and see what happened. Hello from the second. Oh, we still have to actually call it from the C++ module. So now we'll do the same thing. We'll say that the assembly module, it's not going to use name mangling. There's no overloads, so we're going to put it into the extern C block, and we'll just say, void third. How do we know that it's a void function with no arguments? Well, that's just a convenience that happens under the hood with C and C++. In assembly, it's just a label that you're jumping to and returning from. Void means return type. All that means is, I'm trying my best not to make this a C+ or an assembly tutorial, but all that means is there is no return value getting returned. That would be the RAX register if I wanted to move something in there. And then similarly, if I wanted to catch arguments, I'd be grabbing from other registers. So I'm not grabbing any arguments from registers, and I'm not sending a value back with RAX or XMM0 or anything. So that just means it's void and no arguments. So let's do it again. Compile it and then run main. Hello from second. Oh, I sure put in the name mangling thing, but I forgot to call it. Let me do that. Third. So now one more time, compile, and then run it. What's happening in here? Third. I guess I should probably open this up now. Third, ASM, so global third, and then third. Oh, forgot the most important part of a system call. You got to put the keyword or the instruction system call in there. One more time. I hope you're laughing and cringing at home. Trying to make this more fun, maybe. I don't know. Okay, so now it's all working. Notice how we have a bunch of different modules in different languages. We're compiling them all to object files first, and we're linking them all into one executable. And we're doing this in a really, really easy way by using a script instead of typing all the commands out manually. Pretty convenient, right? Let me give you another upgrade real fast here. So this is kind of irritating. I have like all of these object files that I have to specify. What if I forget to specify some? Since this line 36 is just going to be something that goes directly to the shell as a command line, this is not like bash language type stuff, at least for that part. I can just use globbing or wildcards. I can say star.o, meaning I'm going to give every object file to the linker as an input file, and that should just work automatically. Keep in mind if you want to use an advanced strategy like I mentioned earlier, where you have multiple different object files and they've each got their own main functions because they're each going to be their own separate executables, then globbing all object files probably not going to work. You might want to organize it differently somehow, like stick the executable object files or stick the object files for executables in like their own folders or something like that. We're not going to go that far, but I just want you to know. So let's do that again real fast here. We'll say clear and compile, and I'll just try to like run main, assuming that the compiler works. Yeah, so it worked. Everything compiled. By the way, this and end, that means only execute the next part of the command if the previous one succeeded. So if I, clear is obviously going to succeed, and then compile, it might succeed or not. Then I'm going to try to run main. Let me actually do that real fast. Let me show you what I'm talking about. I'm going to remove main. Clear. Okay, so then I'm going to do clear and compile and main. So obviously, if everything works, then everything works. But if I do that again, where something is not actually going to compile, like maybe the C source program is not going to compile by putting some Z's in there, then the .main, that part shouldn't get executed, so it won't try to execute our program. Notice how it just stops. So that's convenient. If I do it again, though, with a different command, if I chain instead of between the commands, instead of putting end to say one must execute before the next one can, if I just put a semicolon, then they will all execute no matter whether they succeeded or not. Maybe in certain things you're doing, you actually want that behavior, but in this case, it's going to be bad. Watch what happens. It fails to compile, and then at the end, it also tries to run a program that doesn't exist because it never got linked because the script stopped. So I'm just letting you know, you have lots of different options when you're writing these scripts. Let me do it again, and then let me fix the Z's. And I think, well, maybe there's one other thing I want you to know. Sometimes these lines get really, really long, right? And it's messy and irritating. At least for me. Maybe if it goes off the side of the screen for you, it's like, oof, that's awful. you can actually just separate a command across multiple lines with a backslash, or sorry, I think that is called a forward slash. It's the drive slash. I don't remember forward slash backslash. I just say web slash and drive slash. So I'm going to do G++ and do a little slash. Then I can put the whole rest of the thing on the next line. If I wanted to, I could start separating these out by category. So maybe I'm like, oh, I don't know, maybe M64 on its own line, and then I'll keep these other two on their own line. And maybe these two on their own line. You know, it's up to you how you organize this. And then I'll say, give me all the input files on its own line, and then the output file on another line. You could even put the OR bars for the die part on its own line. I guess I'll just try that. And now let's just make sure that this still compiles. Let me remove star.o and remove main. It's not there. Okay, so clear and then list. And then 2 showed up somewhere. Oh, my mistake. I probably should have caught that. Some file got saved as a 2. I should have noticed. Okay, so let's do clear and compile, and I'll just run main. Okay, so now everything works. Notice how even though everything was on a different line, it all just seemed to work. Cool. What about repeating code? Because notice how we're kind of doing something here on line 38. We're using the C++23 standard, but we're also doing that up here. And we're also using the all warnings flag up here, and down here, and pedantic also, and even the linker. Like, what if I want to put all warnings into the linker? We could make variables in Bash. And by the way, this is totally starting to become a job for makefiles. But for now, we're just going to stay in Bash. So I can make a variable in Bash. I can say maybe GCC flags, name it something, and I'll just put equals whatever, and I'll just type the stuff that I know is going to appear in every single invocation of G++ or GCC. So I'm going to go wall, because I want to put that everywhere. And I'm going to say C++23, because I'm going to put that everywhere. And probably pedantic I'm going to put everywhere. I'm not going to put the -C flag everywhere, because notice how I'm only putting that on the compiler commands when I just want to make an object file. But when I'm linking, there's no -C, because that means you got to actually link. So let's see, we got gdwarf2, gdwarf2. Maybe I could put gdwarf2 there and see if it still works. So I want debugging symbols, and I want them to be in dwarf-2 format, which honestly is the default format if you just put -G. Let's see if I can get away with that for now. So I'm going to go GCC flags, and here I can get rid of C++23 and wall and pedantic, and I'll just insert instead GCC flags. And if you want to be extra careful, you can put these little braces around the variable name, but that probably should be fine. But because I don't want to type that again, I'm just going to copy paste it into the other commands. So wall, pedantic, just paste that. And then I'm going to leave it alone for YASM, because YASM is different than GCC. And then here I'm going to do another line where I just kind of put the flags. And that means I can get rid of those 2 flags. And then wall and pedantic are going to show up. NoPy is kind of a linker only thing, so is the no exec stack. I think probably that will be okay. Let's see if I got that right or wrong. Oh no! Unrecognized command line option. Wall, pedantic, GCC. Oh, I guess because I quoted it. Shouldn't have done that. Because I quoted it, the command line thought that that was all one argument. I should have remembered. So I'm going to unquote it right now. This should help the command line understand that all of the things inside of that variable, the GCC flags, are separate arguments instead of just one argument. Let me try one more time. Doop, doop, doop. Yay, it seems to work. Okay, we got a warning here. Command line option C++23 is valid for object, but not for C. Okay, so basically I made the mistake of trying to send a C++ object, which is this right here, or sorry, a C++ argument, which is this right here, into a C compiling command. Not great. So what if I did this? I'll do C flags, and it will contain only flags for C. And then I'll have another one for C++ flags which will only contain things that are for C++ compiling. So the regular C compiling can take wall and pedantic, okay, and then it can take the gdwarf2, okay. The C++ flags, it can take everything except for, the C++ flags can actually take all of the C flags, and then additionally the C++ 23 flag. So I could embed a variable inside of itself. I could say C flags, I could embed a variable inside of another variable so that I can just steal all of the flags from the C flags variable, stick them also in the C++ flags variable, and then just add one more at the end of that. Hopefully that works. I think it probably will. Then in my compiling, I can just say, use the CPP flags here, and then use the C flags here, just for compiling. I could probably name the variable better, put the word compile in there or something, but I don't really want to. I think some people put CC to mean like C compiling, but I don't know. I just want to do it this way. So we have that, and then we're going to do CPP flags like this. We could also organize the variables differently so that we could have some linker flags, which basically would probably have all of this stuff minus -C, and then we could have linking flags. No, we can have linking flags that has all that stuff minus the C, and then we'll have like some compiler flags that has the linking flags plus the -C, but I don't really want to spend a bunch of time on this now. For now, we'll just say we have C flags and CPP flags, and we'll just manually add that -C. But of course, keep in mind, you can organize these things any way you want. So I'm going to do, well, this might actually work. I'm getting distracted. I think it works. Okay, let me just double check by removing all the object files. There's a 2 in there still. Let's debug that if it happens again. Then I'm going to remove main. Okay, then I'm just going to list everything real fast. Okay, let's see. Is there going to be a 2 in there now? No, is that only when it fails? Only when something fails to compile? I mean, it's working, so that's good news. You know what? Leave a comment somewhere letting me know where you think I went wrong with this 2. And maybe I'll release another video or something in the future. At some distant point in the future. But yeah, anyway, I hope you learned a lot of stuff in this video and you had a little bit of fun too. This has been, you know, a little intro for compiling, linking, and executing in Linux, but also probably on a bunch of other systems if you have these same tools and you're working inside of Bash. Thank you so much for watching this video. I'll see you in the next one. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.